Okay. Hello students, welcome to my class. Today we are going to study about how to calculate the geometric mean by using logarithms. So many students thought that calculation of logarithms is very difficult, but it is wrong. Calculation of logarithms is very easy. So here we are going to apply the logarithms for calculation of geometric mean, which is coming in the statistics PUC first year. So here there is a data. The data is given here. Calculate geometric mean for the data given below. Here this is the data. You can observe only individual or single digits are given. 2, 7, 9, 4, 5, 6. See how we have to calculate the geometric mean by using the logarithms for these single digits. Okay, so I will write the numbers here. We are considering it as a x 2, 7, 9, 4, 5, 6. So I have written the numbers. So we are consider this as a calculate it as a log x. We have to find the log x for these given numbers. See, for rough calculation I will use the space here. So in the beginning we want to know, so n is equal n minus 1. So we have to consider or we have to calculate the decimal place. First we need the decimal place for the calculation. N is a number of observation, which is the first number here, 2. So it is a 2. So single digits are given here. So n is a only 1. Why we are considering as n as a 1? Because single digits are given. So we are considering this number n as a 1. 1 minus 1 is equals to 0. 1 minus 1 is equals to 0. N is 1. Why? Because only single digits are given. So we are taking it as a 1. When two digits are given here like 23, 27, like 71, 91, two digits are given means we have to take here 2. Because here only one number is given, we have taken n as a 1. 1 minus 1 is equals to 0. We have to start the logarithms with the zeros. Why we are taking all zeros means all numbers are given in a single digit. So we are taking a digits as a single and put the decimals like point here. Next, when two single digit is given, how we have to consider the logarithms, how to calculate the logarithms means when single digits are given in the logarithms table will start from the 2 digits, that is 10. Okay, so here we are having only 2. How we have to calculate this means I will show here. Yes, as 2 is given here, we have to consider it as a 20 at 0. Next is 70 at 0. 90 at 0. 40 at 0. 50 at 0. 60 at 0. So we have to turn the single digit into 2 digits. So 20 at 0. When single digits are given like this means we have to consider it as a 20 at 0. So here we have to search in the logarithm table like this. In the logarithm table we are searching. Where is 20 here? 20 is here. 20 at 0. In the 20th place, the value is 3010. We'll write here 3010. Next, 70 at 0. 70 at 0. Where is 70? Yes, 70 is given here. 70 at 0 is 8451. Observe carefully. 70 at 0. Value is 8451. I will write 8451 here. 8451. Okay. Next, 9 means 90 at 0. 90. Where is 90? 90 is here. 90 at 0. The value is 9542. 9542 is a value. Next, 40 at 0. 40 at 0. The 40 is given here. 40 at 0. 6021. 6021. Next one is 50. 50 at 0. 50 is given here. 50 at 0. 6990. 6990. Next is 60. 60 is given here. 60 at 0. 60 at 0 is 7782. 7782. Next we have to calculate the geometric mean by using this data. Okay, geometric mean. So add all the values given here. Just I will put the total. Log x is equals to, the value is 4.1796. 4.1796 is the total of this. Okay. Next, I will use the space here. I will apply the logarithm like geometric mean formula. GM is equals to AL. AL means anti-log. That is sigma log x divided by n is the formula to calculate the geometric mean. So I will carry the anti-log until the last of this calculation. So what is the total of this log sigma log x value is 4.1796 is the total divided by n. N means number of observations. Okay, n is a number of observations. How many observations given here? 1, 2, 3, 4, 5, 6. Total 6 numbers are given. So n we are considering it as a 6. Number of observation is 6. Next, okay, AL is AL. Next we will get the value 4.1796 divided by 6. So after calculating we will get the value, that is 0.6966 is the value. After dividing the 4.1796 with the 6, you will get the value. Okay, AL, that is 0.6966. Now we have to convert this logarithm value to anti-log. Here the students, you have to give more concentration how we have to convert the log table and log value to anti-log value. So here, from here we are using the anti-log table. Until this we have used the logarithm calculation table for the calculation. From here we are considering the anti-log table. Okay, for this further calculation I will use the rough place to calculate this. Okay, AL 0.6966 is the value. So for the calculation of anti-log we are considering only after point, like decimal values only we are choosing for the calculation. Here see, 6966. Only we are considering a 6966 after point. We are neglecting the before the point, before decimal we are neglecting. Only we are considering the after decimal, that is 6966. In the antilog table we are not calling it as a 6966. There is a different name, like we are calling it as a 69 at 6. Mean difference is 6. Once again I will show here. 69 at 6, mean difference is 6. That is mean difference. I will write here 69 at 6, mean difference is 6. Like this we have to consider for the antilog. I will now I will open the antilog table. We have to search only in the antilog table, then don't get confused. See here, we are searching these values in the antilog table. The 60, we want 69 at 6. Where is 69? 69 is given here. Once again we will zoom it. Okay, 69 is given here. Okay, 69 at 6. 69 at 6. We have to come here again up to 69. See here, 69 at 6 value is, see, 4966. 69 at 6 value is 4966. 4966. I will write here 4966. Okay, we got 69 at 6 value is 4966. Next we have to consider the mean difference 6. See here, mean difference. Okay, 69 at 6 value is 4966. Then we have to search the mean difference 6. See, in the same line where we have selected the 69 at 6, in the 69 line only we have to search the mean difference. So see here, the mean difference is given in this line. These are called as mean differences. 69 at 6 we have taken 4966. Then in the same line we have to search in the mean difference, that is mean difference. See here, 6, mean difference 6 is 7. Mean difference 6 is 7. So I will write in this rough paper, that is 7. I will add 69 at 6 value is 4966. Mean difference value is 7. So after this we have to add this number. Okay, add the numbers 3, 7, 9, 4. Okay, so this is the total of this. So how we have to put the decimal values? 4966 plus 7. So we got 4973. Next we have to put the decimal. Okay, we have to consider the decimal and we have to spot the decimal in this given value. So where we have to put the decimal means, so n plus 1. Okay, so n value already we have calculated here. See here, n minus 1. Okay, n is 1. 1 minus 1 is 0. So here n is equals to 0. 0 plus 1 is equals to 1. So according one digit I will write here. After one digit we have to put the decimal. So one digit, first digit, this is a 1. So this is a decimal. So AL, that is GM, is equals to 4.973. So this is the total. I will write here. That is GM is equals to 4.973. So this is the total value. So this is the overall calculation of our problem. This is the overall calculation of our problem, that is calculation of geometric mean by using logarithms. Once again quickly I will glance the problem. Okay, so single digits are given here. X I am taken as a x, so we have to find the log x, and we have to spot the decimal position. Okay, decimal position. So for the decimal position we are taking it as a n minus 1. So n is a single number here. N is a single number, that is 1. 1 minus 1 is equals to 0. So n is equals to 0. N is 0. So we have to start the log with the 0 values. We are taken zeros for all these numbers because all numbers are a single here. So we are taken zeros. So point. So we will search according to that. We have to search in the log table. So we will get these values and add all these values. You will get 4.1796. Okay, GM is equals to AL sigma log x divided by n. So anti-log, we have to carry this anti-log until the last of the calculation. 4.1796 divided by 6. You will get 0.6966. Okay, so for the anti-log we have to consider only after decimal values. After decimal values. Okay, so after calculation like this, okay, after finally we will get the value of 4.973. Okay, keep learning. Bye bye.